Good day, learners. Welcome back to our chemistry class for today. In today's class, we are going to be taking us through the WAEC Practicals 2025, the predicted questions. I assure you, if you can go through these questions, you will be able to answer the WAEC practical question 100% in quantitative analysis. So I remain Latif Ismaila Akambi, your mathematics and chemistry tutor. You need to sit back to enjoy today's class and make sure you are with your biro and paper to jot down. Don't forget to subscribe to my channel. If you are a new student on this channel, subscribe to my channel and click the notification bell for my subsequent content. And don't forget to share, like, and leave a comment as we move on. So let's move on. The first question we are going to be considering in these predicted questions is question 1. A is 0.1 mole per dm cube HCl. B is a solution containing 15 grams per dm cube of a mixture of sodium hydrogen trioxocarbonate 4 and potassium chloride. A. Put A into the burette and titrate it against 25 cm³ portions of B using methyl orange as indicator. While in this place, WAEC will put 20 cm³ or 25 cm³. Depend on the burette your school is using. If your school is using 20 cm³, you are going to pick the volume to be 20 cm³. If your school is using 25, you pick 25. Now let's continue. Repeat the titration to obtain consistent titers. Tabulate your burette readings and calculate the average volume of acid. The equation for the reaction is HCl combining with sodium hydrogen carbonate to give sodium chloride, water, and carbon dioxide. When you look at this equation, the equation is balanced already. In this case, the ratio of HCl to sodium hydrogen carbonate is 1:1. 1:1. Question B. From your results and the information provided above, calculate the figure 1 concentration of sodium hydrogen carbonate in mole per dm cube in B. Figure 2 concentration of sodium hydrogen carbonate in gram per dm cube in B. Figure 3 percentage by mass of sodium hydrogen carbonate in the mixture. Then figure 4 mass of the potassium chloride in the mixture. In my previous videos, I have taught on the formulae we use in titration. Likewise, I practicalize how to undergo titration and as well how to record our titrations in a table. Don't forget how we normally go about it. If you have not come across that video, kindly click the link in the description box, then watch it and also join us in this one. Let us now interpret our questions. From the question says A is 0.1 mole per dm cube HCl of HCl. Anything in mole per dm cube we know is concentration. Now concentration of the acid is equal to 0.1 mole per dm cube, and B contain a mixture of sodium hydrogen trioxocarbonate 4 and potassium chloride, which is 15 grams per dm cube. That is 15 grams per dm cube of a mixture of sodium hydrogen carbonate and potassium chloride. And anything in gram per dm cube, that is mass concentration. So mass concentration of a mixture of sodium hydrogen carbonate and potassium chloride is 15 grams per dm cube. So after your titration, the question 1 is to calculate the concentration of sodium hydrogen carbonate in solution B. Now, sodium hydrogen carbonate is our base. Let us now look at the information given to us. From this, we have one ratio and another one. That's a 1:1 ratio. Now, we want to find the concentration of B, which is in mole per dm cube. We are given concentration of A in mole per dm cube. We want to find concentration of B in mole per dm cube. Now, the volume of acid that we got from our titration, that is volume of the acid that will come from the titration, will be written here. So it depends on the one that you get in your school. That is, let's assume we have 24.60 centimeter cube. That is volume of acid that we got after our titration. The volume of base is the capacity of the pipette you are using. The pipette you use to suck your base is what we refers to as the volume of the base. Then we use 25 centimeter cube. Now, number of acid here is 1. Number of base is 1. So from this information, we are told to now get the concentration of the base unknown. So from here, we can use one of the formulae that we have taught before, that is CaVa over CbVb is equal to Na over Mb. So let's proceed. Using the formula CaVa over CbVb is equal to Na over Mb. So we want to get the concentration of base. So the first thing is, let's make Cb the subject of the formula. Let's cross multiply the unknown to the left. This will come and meet this. CbVb Na is equal to CaVa Mb. To get my Cb, I will divide both sides by Vb and Na. So I have Cb to be equals to CaVa Mb over Vb and what? Na. Fine. Since I've gotten this, the next thing is to substitute my values. Ca, concentration of the acid is 0.1 multiplied by the volume of acid, 24.60, times number of base, Nb, 1, divided by volume of the base, that is 25, multiplied by 1. So let us multiply the numerator. So we have 2.46 divided by 25. So we divide as well. We have 0.0984. Now, your answer, your calculation should always be to 3 significant figures. We know that these zeros are non-significant. So we start from here. 1, 2, 3. So that is 3 significant figures. So the unit is what? Mole per dm cube. So this is the concentration of sodium hydrogen tricarbonate 4 in solution B. So the next question is to now find the concentration of sodium hydrogen tricarbonate 4 in gram per dm cube in solution what? Solution B. Now, from this solution B, we've gotten the concentration in mole per dm cube. I've gotten that. Now, we can use the second formula that says concentration in mole per dm cube is equals to mass concentration over molar mass. So which means we need to get the molar mass of solution B. Concentration of sodium hydrogen carbonate in mole per dm cube is equals to mass concentration in gram per dm cube over molar mass in gram per mole. So what we need to calculate is the mass concentration in gram per dm cube. So from here we cross multiply. When you cross multiply, this moves here, we have mass. So mass concentration in gram per dm cube is equals to concentration of sodium hydrogen carbonate in mole per dm cube multiplied by molar mass in gram per mole. So let us now find the molar mass of sodium hydrogen carbonate. So molar mass of sodium hydrogen carbonate will be atomic mass of sodium, it should be given, that is 23, plus hydrogen is 1, plus carbon is 12, plus oxygen, that is 16. 16 multiplied by 3. So we have 23 plus 1, we have 24. 24 plus 12, we have 36. Plus 16 times 3, we have 48. So sum it up, what do we have? We have 84 grams per mole. Now you can now substitute into this formula mass concentration Mass concentration in gram per dm cube equals to concentration of sodium hydrogen carbonate in mole per dm cube that we've gotten from here, 0.0984 multiplied by the molar mass, 84. So when we multiply, we have 8.2656. Now, to three significant figures. So we have 1, 2, 3. At the back of this 6, we have 5. Any number from 5 to 9, you round up to 1. When this one becomes 1, add it to this is making 7. So we have 8.27. So the unit is here, gram per dm cube. So that is the second question. So the third question is to now find the percentage by mass of sodium hydrogen carbonate. The third question is to find the percentage by mass of sodium hydrogen carbonate in the mixture. Before we proceed again, if you are a new member on this channel, kindly subscribe to my channel and click the notification bell for my subsequent content. And don't forget to share, like, and leave a comment as we move on. So let us now find the percentage by mass. Percentage by mass of sodium hydrogen carbonate is equals to mass concentration of sodium hydrogen carbonate over mass concentration of mixture times 100. Don't forget the mass concentration is measured in gram per dm cube. Now, the mass concentration of sodium hydrogen carbonate is what we have gotten recently in Roman figure 2, which is equals to 8.27. Then divided by mass concentration of the mixture is 15 multiplied by 100. So we have 8.27 times 100 divided by 15. So we multiply and divide. We have 55.13333 and so on like that. But our answer must be to three significant figures. 1, 2, 3. At the back of this one, we have 3. 3 is a number between 1 to 4. You round down to 0, so we have 55.1. So the unit, since percentage by mass, is in grams. So the last question is to now find the percentage purity. Percentage purity. The last question now is to now find the mass of KCl in the mixture. That is the mass of potassium chloride in the mixture. So this formula will be the mass of mixture, because mixture means two things coming together. It will equals to mass of sodium hydrogen carbonate plus mass of potassium chloride, because the mixture contains sodium hydrogen carbonate and potassium chloride. Now, mass of mixture equals to this. So the mass of mixture that we have is 15 is equals to mass of sodium hydrogen carbonate that we got, we have it to be 8.27 plus mass of KCl, let's say mKCl. Then take this one here, we have 15 minus 8.27 equals to mass of KCl. So my mass of KCl will now equal, so we subtract this. So we have 6.73 grams. So this is how to calculate this. So if a similar question comes this way, this is the way we go about it. So don't forget to like this lesson, share, and leave comments as you leave the channel. I remain your tutor, Lateef Ismaila Akanbi, the Mathematics and Chemistry tutor. Don't forget to meet me in the next class. Thank you very much.